You know, your immune system is, well, it's an absolute masterpiece of biological engineering. It's this incredibly complex, multi-layered fortress of cells and proteins, all working together in perfect harmony to protect you from a nonstop barrage of invaders. Most of the time, it works so flawlessly we don't even think about it. It's just our silent guardian. But what happens when that fortress, our ultimate protector, starts to fail? What happens when the guards can't tell friend from foe anymore, or when the walls themselves are breached? Well, sometimes that fortress crumbles from the inside, maybe because of a structural defect. Other times, as this incredible image shows, it's breached by a really clever invader. I mean, look at that. That's the HIV virus passing between the very cells that are supposed to destroy it. This state of failure is exactly what we call immunodeficiency. So, what does that actually mean? Well, officially, it's a state where the immune system's ability to fight off disease is compromised, or in some cases, completely gone. Now, these failures fall into two main categories, and in this explainer, we're going to break them both down. All right, let's get into it. First up, we have what are called primary immunodeficiencies. The easiest way to think about these is as built-in flaws, errors written right into the immune system's original blueprints. So these are genetic conditions, you inherit them, you're born with them, and they can mess with pretty much any part of the immune system, from the foot soldiers all the way up to the command centers, which often leads to some really serious health problems right from the start of life. You've probably heard of the most severe forms of this, right? It led to the famous case of David Vetter, who became known as the Bubble Boy. He had to live his entire life inside a sterile plastic chamber, totally cut off from a world full of germs. You see, David had a condition called severe combined immunodeficiency, or SCID for short. And this quote, it really just hits you with the reality of it. Without a working immune system, something as simple as a common cold can be fatal. So that last part is key. Early, aggressive treatment is absolutely everything. Okay, I know this chart looks a little complicated, but the story it tells about what goes wrong in SCID is fascinating. Basically, a single genetic defect way at the beginning of this process completely blocks the creation of critical immune cells, your T cells, which are the generals of the immune army, and B cells, which are like the weapons factories. It's basically like a complete factory shutdown before the most important soldiers even get made, leaving the body with no way to learn about and remember new threats. And SCID, as bad as it is really just the tip of the iceberg. Scientists have now found over 300 different genetic defects that can cause these primary immunodeficiencies. Each one affects a different piece of that immune fortress, from faulty alarm systems to weak walls. Okay, so let's quickly recap. Primary immunodeficiency is a problem you're born with, an error in the original blueprints. But what happens if the fortress is built perfectly and then it gets attacked from the outside? Well, that brings us to our second category, secondary, or as it's also called, acquired immunodeficiency. All right, so now we're talking about secondary immunodeficiencies, and these are totally different. They're not caused by faulty blueprints. They're the result of an outside attack on an immune system that was once perfectly healthy and doing its job. What happens here is that a perfectly good immune system gets damaged at some point in a person's life, and that leads to a loss of function. And this can be caused by a whole bunch of different external agents. And the causes can be, well, a whole range of things. It could be severe malnutrition, or the immunosuppressive drugs someone might take after an organ transplant. Even radiation and chemotherapy for cancer can do it. But one external agent, one, is responsible for the most devastating secondary immunodeficiency in modern history. And I think you know what I'm talking about. It's acquired immunodeficiency syndrome, or AIDS, which is caused by infection with the human immunodeficiency virus, HIV. So, how does it do it? How does this one tiny virus manage to hijack and bring down our body's entire defense system? Let's take a closer look at this immune hijacker. First off, you just have to grasp the sheer scale of this thing. Since it was discovered, HIV became a global pandemic. We're talking staggering numbers. Nearly 80 million people have been infected, leading to around 36 million deaths. As this map shows, its impact has been felt in literally every corner of the world. Okay, so from that huge global view, let's zoom way down to the agent responsible for all of it. This is it. This tiny particle, magnified hundreds of thousands of times, is the hijacker. So what makes it so brutally effective? It's all in the strategy. You see, HIV is something called a retrovirus. And its method is, well, it's brilliantly sinister. It literally works backwards. It takes its own genetic code, which is RNA, and uses a special tool to write a DNA version of itself. And then, and this is the crazy part, it stitches that new viral DNA right into the host cell's own instruction manual, its chromosomes. And this slide lays out the attack plan perfectly. Its main target is a very specific immune cell, the CD4 plus T cell. You remember, the general of the immune army? The virus gets in, it does that reverse transcription thing to turn its RNA into DNA, and then it permanently integrates that code into the cell's own DNA. From that moment on, the cell's machinery is hijacked. It's forced to make thousands of new viruses, which then burst out and go infect other cells. It turns our own defenders into factories for the enemy. Just think about that. So what's the end result of this if it's left untreated? It's a slow, relentless war of attrition. As you can see here, the number of those vital CD4 plus T cells just goes down and down and down over the years. Once that count drops below a critical level, the immune system basically collapses. And that final stage of collapse, that is what we call AIDS. But, and this is a really important but, the story doesn't end in defeat. For both primary and secondary immunodeficiencies, science has given us some incredibly powerful ways to fight back. And what's so interesting is that the goals for treating these two types of immunodeficiencies are completely different. For primary immunodeficiencies, those built-in flaws, the goal is to rebuild the system. You do that with tools like bone marrow transplants, or even revolutionary gene therapy, to try and fix the original blueprint. But for HIV, the goal is to suppress the virus, using a cocktail of drugs called antiretroviral therapy, or ART, to stop it from replicating and hijacking new cells. And honestly, the impact of these treatments has been nothing short of profound. While we don't have cures for most of these conditions yet, these therapies have literally transformed what used to be a death sentence into a manageable chronic condition. It's allowed millions of people to live long and relatively healthy lives. So that leaves us with this final big question. Science has given us some incredible tools to fight back, but the challenges that remain are immense. Can we ever truly cure a flaw that's written into our own genetic code? And can we ever completely defeat a virus that has learned to hide within our very own DNA? The answers to those questions, well, they're going to define the future of immunology.